Welcome back, guys, to Java Full Stack Made Easy. And in the previous session, we spoke a lot about overloading. Then we talked about constructors, then constructor overloading. We also overloaded a main method, and then we have seen the rules for overloading, that is, number type and sequence has to be different. And then we have also seen what exactly variable arguments are and how do we make use of variable arguments, rules associated with variable arguments, and all the demos related to this you will find out in session 13 repository here. So you can see we talked about the uh, concept of overloading, then we talked about the constructors, then the while overloading again the type conversion that happens automatically in arguments, that's what we discussed. And then we talked about how do we overload the constructors, and why should we overload constructor, why constructors comes into picture, and how do we initialize the data members of a class inside a constructor, the advantage of using a constructor, and then overloading a constructor, right? So then we spoke about the this keyword as well, which is used to differentiate between a local variable and the instance variable, and why we should give the same name to the local variable and the instance variable. So last session was a bit lengthy, like 1 hour session. So I once again encourage you to go through with that particular session and go through with everything that we have discussed in the previous session. So now coming to the next part of this series and moving ahead in this series, let me talk about the concept of encapsulation for you and how important encapsulation is, where do we make use of encapsulations, and how do we actually create classes in Java. So now, what is encapsulation and how do we exactly encapsulate the data? So encapsulation is nothing but what it is about hiding the data. So we are not exposing the data directly to the outside world. That is what encapsulation is all about. So let me now tell you how exactly we make use of encapsulation. I'll give you one example of it, and hopefully with that particular example you will be able to understand and appreciate the use of encapsulations in any object oriented programming. So what I'm doing here is I'll be writing two classes. So two classes can be written in the same file. I can create separate files and do that. So let me just create a class here, and let's call that class as maybe a class for anything, maybe an employee. Okay, so I'm creating an employee class, and I create variables here like employee name, and I'll also create the age of the employee, right? So an employee class is created with employee name and the employee age. So two properties of the classes are created here, and there will be one function here, that is display function, that actually displays the properties, that is the name of the employee and the age of the employee. Okay, so name and age of the employee should be displayed to me. So this is what I want, and I can write the class this way without giving any access specifier. In previous sessions you might have also seen the usage of access specifier. So as of now I'm not giving any access specifier. If I don't give it to a class, default, not giving it to the properties, that is also default. Even the method is default here. Okay, so I'll come here to the other class and then come down and create a main method and then try to access the class. Okay, so what I'll do is I'll try and access this particular class, this employee class, and then try and modify the values there. So let's create an employee object, employee is equal to new employee, and then I'll say e.display. So if I directly do a e.display now, since I have not initialized anything to these variables, so I'll just get the default values of it. So you see that the default values, employee name, oh sorry, name should be of type string, that's why it is giving me 0. So name will be null and age will be 0. So nothing is initialized, looks good, that's fine. So now what I will do is I'll have a constructor maybe here, and then try to initialize these values inside a constructor. So let's create a constructor like this, employee. Okay, so I don't want to create a default constructor. A default constructor is one that doesn't have any argument, right? So I'll not create a default constructor, but I'll directly create a constructor that takes argument. So when I'm creating a constructor by my own, a default constructor will not be created. So if I don't create any constructor, then a default constructor is already created for me. So I'll create a constructor employee and I'll pass in two values here, that is int age and then string. So I can directly right click and generate a constructor, right? So we have seen that in the previous example. So just right click source, generate constructor using field. So that's what I'll do. I'll generate the constructor using both the fields. That's fine. So everything is done. If we don't write this super, still it is there. We will understand what exactly is that in our later session. So as for now, let's just create a constructor and initialize the values. So I am creating the constructor and initializing the value. So first argument is what? Employee name and then employee age. So I'll give the employee name. Let's say maybe Rohit is the employee name I am giving, and second one is the age of the employee I am giving. Let's say 45 is the age of the employee. So I'll save it and then run it. So I'll get the details. So display is being called and the details are printed to me. So what I want now is that these properties that are created, no, this is the employee age and the name that is created. So what I exactly need is, I don't want anybody to give me the values like this. I don't want -45 to be given here, right? So if a user gives me invalid values like -45, user cannot have a age like -45, right? So that's an invalid age. So I want the age to be in a valid range, like it should be greater than 0. If it is greater than 0, then only accept it, else do not accept it. Give it as 0. So 0 indicates that it's the age is not given. Okay. So what I will do now, so in this case I have an option. So I can simply say if the given age is greater than 0, then only do this dot age is equal to age, else keep the age as 0 itself. Okay, so now if I save it and run it, it looks good. So now employee's age that is being passed by the user is 45, so which is an invalid age. So I'll just be making it as 0. We still don't know the exception and all. We can terminate this program when the user has passed the age as -45 or something. But as for now, we are not accepting any negative age, right? So this is fine. But what can happen in these in scenarios like this? I have already implemented a logic there. That is, I am not accepting any negative age, right? But because my properties are exposed to the outside world, what the outside world can do is, before doing a display, somebody can come up and say e dot age equals to -45. So when a user does this -45, so at that time what happens is the age is still accepted as -45. So here comes the problem, right? So we are trying to expose these properties to the outside world directly. Because we are exposing these properties directly to the outside world, what is happening is the outside world is able to modify these properties directly, and they can give invalid values as well, right? So this is the problem statement first. So let me create another repository as D14 and give you the problem statement first, and then give you the solution for that. So this is our D14 slash let's go for what, demo1 problem. Okay, although we have created a constructor and we are initializing the value through a constructor, and we have passed in a check through a constructor, now we cannot force user to only pass the value through constructor, right? We have created a check here and we are not accepting any negative values, but what a user is doing is, because this property is exposed, user is actually giving us a negative value. So what is the solution for this? The solution for this is, make your properties as private. So private employee name and private age. So when you make it as private, so at that time there is no chance that the user might give you the age like. Okay, so negative age will not be accepted now. So what is happening here? We are encapsulating, we are hiding the data to the outside world by making it private. So what we can, what a user can do is, user can only go through with the constructor and then change the value of the age. Now there is one more problem here. So we have already given a solution to the previous problem that was raised. Now there is one more problem. What is that problem? The problem is that if I give some age to the employee here, that is maybe by mistake I have given it as 45, but for the same object I want to change the age. Instead of making it minus 45, now I want to give it a valid age. Maybe I want to give it as 20 or something, but I cannot change the value until and unless I have a constructor, right? So if I use the constructor, at that time what happens is I'm creating another object. So without creating object, still I want to change the value of this variable. What I need to do in that case? So that is the problem, second problem. So first, I have already given a solution for the previous problem that we discussed. Error: cannot access age as it is private. Okay, so by making it private, we are not exposing the property to the outside world. So this is the solution for that. Demo 2 solution for the problem that we faced in the previous program. What was the problem? The problem was user can set the invalid age. Now there is a problem again. Now what is that problem? The problem is that, once again, I'll put the same thing as a problem. Demo 2 is a solution for the previous problem, but in this solution also there is a problem. What is the problem? Problem: once age is set, it cannot be changed. That's a problem, right? Why is that? That is because once the object is age is set during creation of object, once the object is created, you cannot change the value of that age unless you take again what? You take the constructor. If you are creating a constructor again, that means you are creating a new memory. Again, new set of variables will be created, but this particular object's properties are not changed, right? So how do we do that? So for that itself, we Java provides us one more concept where you can set the values of these private properties, and those things are called as accessors and mutators, or you can call it as the getters and setters. Each property that you declare in your class, you must follow those properties with the getters and setters. So you can see that again there is a function here called as generate getters and setters. So I want to generate the getters and setters for both employee name and the age. So I'll just generate that, and once I do it, then here I go. Now what I can do is, after creating the invalid age, I still have the ability to go for e dot set age. Now in the age, I'll give the valid age as 20. So I'll save it and run it, and you can now notice that initially I gave an invalid age, because of that the age was 0, and now I'm setting a valid age, the age is 20. So you'll see it here, display. Initially I was setting an invalid age, so it did not accept that, so that's why it is 0. Now I'm setting a valid age. Now what if somebody gives minus 20? Minus 20 should not be accepted, right? So minus 20 is what I'm giving. Okay, great. So what I have to do is, even in the setter of this age, I have to put this check which I have already added inside the constructor. So this check again has to be added inside the set. So if this happens, then only set the age, else you don't do anything at all. So that case, even if you provide an invalid age, even after giving the value, it will still not accept the age. Now only the age that is acceptable, which is greater than 0, will only be accepted. So this way you can even have the checks. So that's why your setters are very much important. What you are actually doing is, you are creating a check there. If any value is coming through setters, you have the option to modify or check those values. If the value is valid, then only allow the variable to be modified, else do not allow the variable to be modified. Similarly, you have the option of checking the values here inside the constructor as well. So for a class, whichever class you are creating, it is best practice to create a constructor as well as the setters and getters. Why is that? That is because sometimes you may want to change the value after creating the object. So if you want to change the value after creating the object, setters will come into picture. And what is the use of this getters? Getters, they give you the value of the age. If there was no display method here, then what is my option to get the values? The option to get the values, if the display method is not there, then you have the option, that is, you can simply say system.out.println, or even if there is a display method available for me, and display method is doing what? System.out.println, but I don't want to print the age on a console. I might want to print it on what? J option pane. So I have an option there, right? So like if I just want to print the age, system.out.println, e.getAge is an option for me, by using which I can simply get the age. Now I am printing it on the console. I know that we can print it by using a joption print.show message dialog and then print it on a console as well. Or else if I want to take this age and then subtract this age with the current age and see what exactly is the date, year of birth at that point of time, will give me in what year the user was born, right? So I can manipulate the age as well. I can get the name of the employee and then check, or maybe if the employee name is starting with just R, so I can sort it out, or I can play around with the values. So that's why even the getters are important there. Fine. So I hope you got to know the advantages of making use of the getters and setters and also the constructor, right? So what we are doing is we generally, and this is the best practice of programming, so you have to make your properties as private because you don't want your properties to be exposed to the outside world directly. Fine. So that is why you have to always ensure that you keep this properties private with you. Okay, always keep them as private. Then what you do is you try and access it through the accessor and mutator, or you access it through the constructor. Okay, I hope this is clear to you. I'll just put this into the repository and also give you one scenario where you will appreciate this concept. I'll go for demo 3, setter and getter. So these are some very important methods that has to be added into any model class that you're creating. For example, yeah, one more. I told you I'll give you one more example where you will appreciate the concept of using the getters and setters, or maybe data hiding concepts, right? So what is that? That is, let's take an example of a let's say an ATM machine itself. Okay, let's create a class for an ATM machine and then see how things work there. So for now I will just remove this employee class and also remove the objects and everything that I have created here. So what I will do is I'll create a class and I'll call it as an ATM class, and in an ATM class C should be in small case. So in an ATM class, what I have is I have a pin, ATM pin, right? So which can be anything, maybe let's say it is 1111, and then what I have is I will be having something like int balance. So there are two variables that are created for us. One is what the pin which will be entered by the user, and then the balance, right? So let us say that the balance of the user as for now is 100 rupees. Okay, so we can definitely create we can get this balance from the database, and all those things can be done, but because we have not yet connected to the database and for every particular user we don't have an exact balance, all that is secondary thing. But just consider, this is as if like we are imagining this situation, hypothetically we are imagining this situation that the user's balance is 100 as for now. Okay, so what I will have is I will have functionalities into this particular ATM class. The functionalities would be what to check whether the pin entered by the user is valid or not, and then I want to withdraw some amount, and then I also want to get to know the balance as well, right? So I want to perform these tasks, that is I also want to deposit the money there so that I can increase the balance and all that. So what I will do is I'll first create a function that will tell me whether the entered pin is valid or not. So to check that, what I'll do is I'll just create a function. Validate pin is a function which I'll create, and this function, what it will do is it will take an int pin for me. Sorry, validate pin. It will take a int pin from the user, and it will check if this this dot pin equal to the entered pin or not. So if this is valid, what I want is I want to return it as true. Okay, so what I want to check is if this dot pin equal to the pin, then return true. Okay, that's what I want to do, and this method will obviously return a boolean value because we are returning true here. Okay, so that's fine. And says pin, that's correct. So this dot pin equal to pin, return true, and else return false, or just we will write a return false in all the other cases. In all the other cases, just return false. Okay, so only in one case it will return true, it will validate the pin if the pin entered is the correct pin, that is 1111. As for now we are imagining that. Then the next thing is I'll create a withdrawal method. Okay, let's say void withdraw, and in the withdraw method what I will ask the user to enter the amount. Okay, int amount, and what I will do is if the amount entered by the user is less than or equal to the balance that we have already, in that case we will subtract the balance, so which will be balance equals to balance minus the amount. Okay, so I can directly write minus equal to amount. So it is same as what this minus equal to amount is same as writing balance is equal to balance minus amount. This if you write this or this, both are same, and this is called as what? This is called as arithmetic assignment operator. We are performing an arithmetic operation as well as at the same time we are doing a assignment there. That's why it is called as arithmetic assignment operator. So one withdrawal functionality I have written here. Fine. So I will just test this, that is I will try to perform a withdraw, and then I will try to just check the balance as well. Yeah, and for also to check what is my balance, I have not written the functionality for balance. So I'll simply generate a getter for a balance as for now. So generate getters and setters. For balance I will generate the getter and the setter. So as for now what I will do is I'll not generate the setter for it. Okay, so I hope that this class is pretty much clear to you. What I have is I have simple functionalities there. One is pin, another one is balance, and then one is validate pin. If the pin is validated, then we are allowing the user to perform a withdrawal functionality. Okay, so let's try to call this and then see how things work there. So first of all, I'll try and call the validate functionality. Here also a user is going to give me the entered pin. I can ask the user to give a scanner and then take the pin and everything. Okay, so maybe user has given 1 2 3 4 for us. If a user has given us 1 2 3 4, so first I will call if the validate pin functionality. Sorry, so first let's create the object of that ATM. The object of ATM is created as ATM itself is equal to new ATM, and then we go and here I will say ATM dot validate pin first. Because validate pin returns us what? A boolean result. It might return as true or might return as false. So entered pin is 1 2 3 4. So I am checking if that is validated or not. If it is validated, that means if correct pin is entered, then call what? ATM dot withdrawal. And while withdrawing, we will also ask the user to enter what? The amount. Here itself I can ask the user to enter the amount. So as for now I'm just taking the amount should be, let's say, 50. Okay, int amount equals to 50. Withdraw what? Withdraw 50 here. Okay, and after performing an withdrawal, just show the balance to the user. So I'll do a ATM dot get balance, and I'll just print this system.out.println ATM dot get balance. So print that balance, and before this withdrawal also I'll show just the balance system.out. As for now, let's remove that and first see, let's just see the functionality first. And in else case, system.out.println, wrong pin is what I will add here. Okay, so let's save it and first test our application whether it is working perfectly fine or not. So pretty simple and straightforward code I have written. It'll enter the pin, that is 1234 is the pin that is entered now. It will validate the pin, and what valid pin we have written there, 1111. User is trying to enter 1234, so it is invalid. It has to go to else block and it says me wrong pin. That is correct. So 1111 is my valid pin. So when a valid pin is given, then it should enter into this if block. So withdrawal of 50 should happen, and then balance should be returned back to the user. So you can see that balance of 50 is returned back to the user, and before withdrawing something, I will also do a system.out.println and I'll do a atm.getBalance. So I will save this and run this piece of code. So before it was 100, after withdrawal it is 50. So I can write a system.println after withdrawal. Okay, so after withdrawal it will be 50. So before it was 100, now it is 50. Now how do we bring in encapsulation into this, you might ask that, right? So you notice that in this case also I don't have any int pin is not set to private, balance is not set to private. So what a user can misuse in such situation is that user can come up and say, oh, you have made the balance as non-private, right? So user can come up and say atm.balance is equal to 5000, right? So we are able to change the balance, and now the remaining balance is 4950. So here are the things where things can go complicated, right? So if you expose your properties, then people can play around with your properties. So that is why you have to ensure that your properties are not exposed to the outside world. You must bring in the concept of encryption into it, that is encapsulation into it. So that is why always, if you don't want to allow this, possible if your property is not private, right? So that's why you have to do what, make this balance as private. Now you might say, okay, I made it private, but if you do a generate getters and setters, then you can set the balance. Now because we don't want to set the balance, we only have the getter method, right? So we are not setting the balance, we are not changing the balance. Balance can be changed only after you implement a deposit functionality. So if you implement a deposit functionality, then it will be what, deposit takes the amount and then it will make what, balance will be equal to plus the amount entered by the user. So this way we can bring in the security into our applications, and that's why we bring in the concept of private data members. And I don't want the users to change the ATM pin directly. They should not have the access to change the pin. So that's why again I will make this also as private. So hopefully you have understood why should we make properties as private, and how do we expose the properties to the outside world. If you want to expose the properties to the outside world, use the getters and setters. Without using getter setters, do not expose it directly, else they can completely change the functionality or completely change the value of your properties, which in turns can change the entire application. So hopefully this example, with this example you have got to know the use of access specifiers, accessors and mutators. So demo 4 ATM example. Okay, so this is where we make use of the concept of encapsulation. So we can also bring in the another data hiding concept, that is abstraction, where again we hide the way how the functionalities are created, how the methods are created. We just expose the method, but we hide the implementation details of it. So we will see that when we come to abstraction. Okay, so by now I hope that the concept of creating getters and setters and the constructor and creating properties as private is completely clear to you. Okay, so now I'll just clean up everything that I have written. One more simple example I'll give you about another object, and after that we'll move to the other topics. So I'll clean up this once again, and I'll bring back my old example, that was the employee example. So let's go to the employee example where we use the getters and setters. Employee class looks good. So whenever we are creating this pojos, what is this pojo class now? Plain old Java object, pojo class. So classes like this, the classes that are created like this are called as pojos. So in Java we either call it as pojo class, or we call it as model, or we call it as bean classes, okay, or we call it as entity classes. So all refers to the same itself. A business entity, okay, is called as a pojo class, plain old Java objects, or you can call it as a model, or you call it as an entity, or you call it as a bean class. So as the session progresses, you will understand the creation of entity classes, or creation of bean classes, or maybe the model classes. Okay, so here I have created an employee, and now the getters and setters, the display method, everything is created there. I don't want to have a display. So display method, what is the purpose of display method here? To display the details about the employee, right? The display method just displays the details of the employee. Rest all things that I have created are all auto generated, right? This constructor was auto generated, setter auto generated, getters auto generated. Only in the setter and the constructor, this checks I have added explicitly, rest all is auto generated only, right? So what I will do as for now is, again, I will remove this employee class and everything that I have created into the employee class. Okay, and you see how easily your employee class can be created. You create just the two properties, and then what you do is you generate everything else. Right click, source, generate the getters and setters for this. So I generated getters and setters. Then generate the constructor using field. Okay, so constructor using field generated. For this class I will also generate a default constructor. As for now there is no use of this default constructor, but later I will show you why it is important to also provide a default constructor into our class. Okay, then lastly there was a display method here, right? So which was displaying me all the employee details. So let it be as for now, I will not create it. Let's create the object of this employee and understand how do we see the details. Employee is equal to new employee, and then the employee's name and age can be provided here. So which is Rohit, and 45 is something, or maybe 40 is the age, is what I want to initialize. Let's save it, and then employee.display. So is there a display function here? No, display function is not created. So I'll just try to print this object, employee object, and see what is there in that employee object. So system.out.println, I am just trying to print the employee object and see what is there in that employee. So save it and run it. You don't you see a hash code here, right? So you don't understand what is there in that employee object, right? So for that, again, your this is again such a common practice that you can just right click and generate a toString method. Now what is this toString method? And also you can select the fields in the toString method. So I generate it, and you can see that there is something called as override annotation coming up, and then there is a toString method I am writing here. So this toString method actually belongs to the object class, because the object class is a parent class for all the classes in Java. Child classes can override the parent's method. So what happens, what is the advantage of using this toString method? The advantage is that in the previous example you might have seen, without having a toString method, when I was printing this employee, it was showing me this, right? It was showing me this. Now what I will do is, after implementing this toString method, when I run this, you see that it is showing me the details of the employee, right? So do you think that there is a use of this toString method? Yes, obviously. If we want to just print the object and see all the properties inside that object, you just implement a toString method and you should see the details about that particular object. So this is the standard that we generally use in Java programming, and we override this toString method. We generate the getters and setters, we write the constructors. So these are something which are very common in every Java class. You see that. Okay, you create the properties. So in this employee class, I have done nothing except creating just two properties. Rest all things are all auto generated. Getter setters I generated, employee constructor I generated, default constructor I generated, and then I also generated a toString method. So this is how common practice it is in Java programming, and the use of this toString. So that means whatever you return in a toString method, whenever the object of that class is printed, that will be printed. That means if suppose in this toString method, instead of printing all of this, if I just say this is to str output, okay, so the result when I print this employee object, I'll get this result. This is to str object. Fine. So that is why this is created, where we are saying that it is an employee's object, and the employee name is the employee name, age is the age, and all that. Fine. So if you want to print the objects, then you have to bring in the concept of toString method into your class. So hope you have got to know the use of even the toString method here. So let me put that into the repository as well. A lot of toString method, generating getter setters, generating constructors, we will do in the future. Demo 5, toString method. Okay. So in this session, we have actually seen why should we encapsulate the properties, and then what are the getters and setters. Constructors already we have seen in the previous session itself. In this session we utilized it. How can we use setters to provide in the check, like in this example where I was giving the age as negative, and then I checked if the negative age is passed, then do not accept those values. That is what we have checked. And then we have seen what is the use of a toString method. So I will stop the session here itself. So in the coming up in the upcoming sessions, we will be talking about concept of inheritance, and when we talk about inheritance, I will tell you details, more details on this annotation @override, and in this example, whether I write it or not, it is same itself. Your result will be the same irrespective whether I write that override or not. Annotations were again introduced into Java 1.5. So in 1.5 there were a lot of things introduced into Java. It brought in a huge change into this particular version 1.5. Annotations were introduced, like in enhanced for loop, I told you, was introduced into Java 1.5 itself. Generics were introduced into 1.5. So there are a lot of things that were introduced into 1.5. That version itself is called as the Tiger version of Java. There are a lot of changes has happened. So in the next series, in the next session of the series, we will be talking about inheritance, and there I will show you what is the use of this @override. In the previous session we talked about something called as function overloading, and in the next session we will be talking about something called as function overriding. We will see the rules of overriding, what exactly is overriding and all. So in the previous session, if you remember, I have shared the assignments for you for the string classes, right? String classes, string buffer, string builder. So I hope that you are about to finish the exercises, this exercises and the array exercises. Obviously it will take some time for completing these assignments, but I want you to complete this assignment so that you have a hands-on practice on things that you are doing here. Okay, this session is not only a theoretical session. This session I'm aiming to bring you closer to actual world, real world programming. Okay, so I hope you have enjoyed this session. So see you in the next session. If you have any doubt, any questions, you comment on the video, and if you are following the series, please like the videos so that I get to know that people are actually following the series and wants the series to be continued. So you do comment if you are following the series. Encourage me to create more such content. See you in the next video. Thank you.